Hello friends, this is OPSC PGT in STSC Development Department question paper, which one is the PGT question paper. Here I solve only numerical analysis question. These questions start from question number 41 and ends in question number 50. So there are 10 number of questions are asked in OPSC PGT question. So here let us start. So first of all, which numerical method to find solution of transcendental equation converges faster? So this one is Newton's method. So because in Newton's method the rate of convergence is defined as 2. That's why we write the rate of convergence. This one is the faster rate of convergence. So option B is correct one. Now come to question number 42. Here the question asks that the rate of convergence of Newton's method is how much? So the rate of convergence of Newton method is 2. This one is the well-known data or well-known formula. Now come to question number 43. So here the question asks that for which of the following function x square equal to 5 is a fixed point. So x square equal to 5, that means what is the value of x? This x is equal to root over of 5. So this root over of 5, and we have to find which function, which gx or which function is the fixed point iteration function. So in fixed point function, we know that the formula, a function that is, if we write this function as phi of x, then this phi dash x, this mod is always less than 1. So here this g dash x is nothing but 1 by 5, and this mod is always less than 1. Similarly, if we find the value of this g dash x, here we get this one is 0, then plus this one is 4 into, so this one is mod of 4 into minus 1, and this one is x plus 1 whole to the power minus 2, and this mod, this cannot be this, this not is equal to 1. Clear? By putting the value of x equal to root 5, we cannot get this quantity equal to less than equal to 1. Similarly, here our function is g of x, and on differentiating this gives this one is 2x minus 4. This mod is when put x is equal to root 5, here we cannot get this quantity also less than 1. And similarly, for this g dash x is this value here is root over of 5, and this mod is never less than 1. So our fixed point function, this one is phi dash of x is always less than 1. So this a bit is correct one. Now come to 44. So here the value of third order forward difference from the following data is how much? So third order forward difference here. So we know that the forward difference operator, that is forward delta of xi, this gives the value, or this is there is a formula. So this formula is f of xi then plus h minus f of xi. Clear? And for better, if we write the table, then we get the simple. So here x given and f of x also given. So let us here write forward delta of f and forward delta square f, and here is the forward delta cube f. And we know that the formula of delta f, forward delta f, this one is 27 minus 13, 27 minus 13. And similarly here we get the value h, this one is 14. Similarly 49 minus 20, 27, here we get the value is 22. And 73 minus 49, here we get this one is 24. And similarly this minus this, we gave this result, give this one is 8, and from this minus this we get this one is 2, and from this and this we get this one is minus 6. So this one is option D is correct one. Clear? So now come to another question, that is question number 45. Here the question asks that which interpolation is used for equispaced data. So equispaced data, we know that Newton forward interpolation. This one is the equispaced data. Here we only use equispaced data. In Lagrange interpolation, it is not necessary that the data interpolating nodes are equispaced. Similarly, in Newton's divided difference also and spline interpolation also. Clear? So option A is correct one. Now come to 46. So which is related to trapezoidal rule? So here some formula is given, and here option number B is correct one. This one is the direct formula of trapezoidal rule, that is h by 2 into y naught plus yn plus 2 times y1 plus y2 plus up to, these are dot dot dot, not comma, and up to yn minus 1. This one is the correct formula. This one is the direct question. So now come to 47. Clear? The local truncation error for Euler method is how much? So here this one is order of h square or big O of h square. Clear? This is the local truncation error of Euler method. Similarly, now come to 48. For Simpson one-third rule, the number of subintervals n must be how much? We know that in Simpson one-third rule, the subinterval must be the even number of. So this one even is the correct answer. Clear? Now come to 49. Here the question asks that the Runge-Kutta method is applicable to solve. This one is the first order ODE only. And now come to 50. Here in Euler's method to solve ordinary differential equation. So which one is the ordinary differential equation? Which one is the formula? In this case, the option D is correct one. That is yn plus 1 equal to yn plus h into f of xn comma yn. This one is the formula for Euler method. This one is the formula, nothing else. So if you remember this question, then you can solve easily. So thank you. In this video I only explain the numerical analysis question. So stay tuned. If you like my video, then please subscribe my channel, and in upcoming video I will provide the other